Okay, actuary dude here, and let's have a look at another exam question. So let's start at A. Calculate the time in days for £3,600 to accumulate to £4,000. So AI is, we're going to use a simple interest rate of 6% per annum. So what do we have? We have 3,600, we're keeping it there, times our interest rate, an annual one, times our some amount of days over 365, and that's going to equal 4,000. Alright, so let's have a quick look at what this might be. So transposing it all to get D by itself, 4,000 divided by 3,600, make a minus 1, is that bit over there. We're then going to have to do that divided by 5, and we're going to times it by 365, so I think we can times it by 365 divided by, sorry, not divided by 5, divided by 0.06. I don't know where 5 came from. Will give us that. So D is 676 days. Okay, so that's all good. D equals 676 days, which makes sense. Not everything has to fit into 1 year time frames. Okay, so now let's try it again. Compound rate of interest, 6% per annum, convertible quarterly. Alright, so we know what I4 is. We know what the effective quarterly interest rate, which is 1.25%. So let's find out what the annual effective rate is, and then we're going to have to start transposing some the compound rate, which I imagine we're going to be needing some logarithms for. Okay, so as we know, it's going to be 1 plus the quarterly rate, so in fact 1.015 to the power, so compounded quarterly, minus 1 will give us this annual effective rate, so 0.0613, 0.0614 actually. Okay, and there we go. That's a per annum. So now let's have a look at this compounded bit. So 3,600 times 1 plus the interest rate, so 0.0614. We'll use Excel to get a more accurate number. We're going to put it to the power of D on 365, and it's going to equal 4,000. And I can already see that we're going to need to use a log for this. So let's just quickly sort of work something out if we can. We're going to be making it, let's just take the log of both sides, and well, let's first take 3,600 to this side and then take the log. So we're going to get ln, which means we can plug it, D365, that of 1.0614 equals the natural logarithm of 4,000 on 3,600. We can divide the logs and then times it all by 365, so it'll be ln 4,000 on 3600, and of course we can simplify things here, but I have no problem doing it like this, and then we're going to times it all by 365, and that'll give us our D value. So let's find out what that is. So how many days are there? So let's find out equals, in fact I'll put that in brackets as well, the natural logarithm of 4,000 divided by 3,600, all of that divided by the natural logarithm of 1 plus this new interest rate that we'd worked out, the effective one, and then we times that whole thing by 365. We get 646 days approximately. So 646 days, which is in fact less. It takes less time to accumulate the same amount of money when we compound it. Who would have guessed? And the third bit is a compound rate of interest, 6% per annum, convertible monthly. So it's basically the exact same thing, but instead of this bit over here, we're going to have a new effective rate. So we know, basically, we can work out that the monthly effective rate, I'll even type it down, monthly effective rate, and that's equal to 0.06 divided by 12, is that bit. So let's find out the annual effective rate. I'll put it over here, and I'm going to say equals 1 plus that bit there, and then we're going to put it to the power of 12, and then we're going to minus 1 from the whole thing. So we get a slightly higher effective rate because we're compounding over more periods, so that's more interest earned on more interest. And so now, instead of using A1, cell A1, let's use cell A2 in our equation. So right here, I'll just fix this up, and there we have, it's going to be the exact same formula, but now it's going to be 643 days that it's going to take. So I'll even just show how that will look. So that's going to be 3,600, 1.0, just like that. D on 365 equaled 4,000, and so then that was going to be D equal ln, the same thing as before, divided by, and here's the natural logarithm of our new effective rate. And that's all that really changed, times 365, which then equaled, I can't remember the number, it was 643 days, which is less than the previous one. So explain why the amount takes longer to accumulate in part A. And I guess the reasoning for that is because we are not accumulating, we are not earning interest upon interest over here. Okay, in simple interest, that's not how it works. And if it wanted to get in more detail, the difference between II and III is because we'd be earning interest on more periods, so more interest and more interest would shorten the amount of time it takes to accumulate to get to the same value. So thank you for watching.